Welcome to Metrology lecture series. In the present video, we will discuss the RA value calculations for the different surface profiles, and also we will discuss the gate previous problems on RA value calculations. RA value is determined by CLA or centerline average method. Centerline average or arithmetic average is defined as the average values of the ordinates from the mean line regardless of the arithmetic sign of the ordinates. So RA is defined as the total surface area divided by sampling length. So let's observe the schematic picture. Here capital L is the sample length and A1, A2, A3, A4, A5 are the represents the areas of the surface roughness. Then RA value is the A1 plus A2 plus A3 up to the AN divided by capital L. So RA we can be represented as the summation of all the areas divided by capital L, that is RA equal to summation of A divided by L. So mathematically we can be represent the RA value RA equal to the 1 by L into integration of 0 to L Yx dx, where the L is the sampling length and y of x is the deviation from the mean line. So next we have to discuss the RA value calculation for the different surface profiles. First we have to look for the rectangular profile. So in this schematically we have to representing the rectangular profile which sampling length is the capital L and total peak to valley height is the capital H. Then mean line will be at the h by 2, then height above the mean line is h by 2 and depth below the mean line is the h by 2. So we know that one the RA equal to 1 by L into integration of 0 to L Yx dx. Here Yx is the deviation from the above the mean line. Here deviation from the above the mean line is the h by 2. Then RA equal to 1 by L into integration of 0 to L h by 2 dx. So this can be we written as 1 by L into h by 2 into capital L, where capital L and the capital L will get the cancel. Then RA equal to the h by 2. So RA value for the rectangular profile is the h by 2, where the h is the total peak to valley height. Next we will discuss the symmetrical triangular profile. Symmetrical triangular profile surface look like the continuous sharp peaks and the valleys. Then this profile is symmetric about the mean line and peak to valley height is the, let's consider capital H. Then its amplitude, that is the mean line to peak is the h by 2. We know that one RA equal to area under the one cycle divided by sampling length. So first I have to calculate the area of the one triangle above the mean line. So above the mean line there are the, so two triangles are there. So first I have to calculate the area of the first triangle. So this is the look like the right angle triangle. Then area of the right angle triangle will become the, so of base into height. Here base will become the L by 2 and height will become the h by 2. Then area will become the, so 1 by 2 into L by 2 into h by 2, which is equal to the LH by 8. But here above the mean line there are the two triangles. So there are the two identical triangles for the one full cycle. Then total area will become the 2 into LH by 8. So which is equal to the LH by 4. So next we have to calculate the RA value, that is total area divided by the sampling length. So where the total area is the LH by 4, sampling length is the L. Then RA equal to total area divided by L, which is the LH by 4 into 1 by L. Here L will get the cancel. Then RA value is the h by 4. So triangle area is the half of the rectangle. So RA value will becomes the h by 4. So next we have to look for the another profile, that is the sawtooth profile. So in the sawtooth profile, surface rises gradually from 0 to h. Then it is suddenly drops to the 0. Then profile is not symmetric about the mean line. It is a linear ramp. So area under the one ramp will become the, so this is the look like one rectangle triangle. So area for the, so one cycle, one ramp, which is equal to the half into base into height. So base is the L, height is the capital H. Then area equal to the LH by 2. So we know RA equal to the total area divided by sampling length. So here total area is the LH by 2 and divided by capital L, which is the RA. So RA equal to LH by 2 into capital L. Sorry, here capital L. Here capital L and the capital L will get the cancel. Then RA equal to the H by 2. Next we will discuss the RA value calculation for the sinusoidal profile. So for this profile, surface look like say smooth sine wave and it is the symmetric about the mean line. And let's consider the peak to valley height is capital H and its amplitude. Let's consider small a, that is the mean line to peak is the H by 2. Moreover, have to consider the sampling length is the capital L. Then sine wave equation is the y equal to the a sine of 2 pi x divided by capital L. Since the sine wave is symmetric, then we have to calculate the half cycle and multiply by the 2. Then RA will become the 2 by L integration of 0 to L by 2, a sine of 2 pi x divided by L into the dx. So if you integrated this one, we will get the RA value is the 2a by pi. We know that one the a is amplitude, that is the h by 2. Then substitute a value, then RA value we will get the h by pi. So this is the summary of the RA values for the different profiles. So for the rectangular profile, RA value is the h by 2. And symmetrical triangular profile, RA value is the h by 4. Sawtooth profile, RA value is the h by 2. And sinusoidal profile, RA value is the h by pi, where the capital H is the peak to valley height. Next we will discuss the gate previous problem on RA value calculations for the different surface profile. So first problem is the roughness profile of a surface is depicted below. The roughness parameter RA is, so this question is asked in the GATE 2016 for the production and industrial engineering paper. So let's see the solution. So we know that when the RA value is average of the absolute heights of all surface points measured from the mean line. So RA equal to the H1 plus H2 plus H3 up to the Hn divided by small n. So here observe the, so number of heights are the above the mean line and below the mean line. First we have to look for the above the mean line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. And below the mean line, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So total number of irregularities are the 17 above the mean line and the 17 below the mean line. Then total number of irregularities are the 17 into 2, that is the 34. and height of the each irregularity is the 2 microns. Then RA equal to the summation of the all these heights divided by number of irregularities. So RA value is the 2 into 34. So here each height is the 2 and total number of irregularities are the 17 plus 17, that is the 34. So summation of the all these 34 heights will become the 2 into 34 and number of irregularities are the 17 plus 17, that is the 34. So RA value equal to the 2 into 34 divided by 34. So 34 will get the cancel. Then RA value is the 2 microns. So our answer is the RA equal to the 2 microns. So next we have to see the one more problem. So this question is asked in the GATE 2015 for the production and industrial paper. So let's see the problem. A surface is prepared especially for an application with the profile as shown in the figure. Then theoretical RA value for this surface is in microns. So here it is given the rectangular profile. So we know that when the RA value for the rectangular profile is the RA equal to the h by 2. So where the capital H is the peak to valley height. So here peak to valley height is given the 5. So RA value is the 5 by 2, which is equal to the 2.5 microns. So answer is the 2.5. So next I have to go for the one more problem. Consider the surface roughness profile as shown in the figure. The center line average of the measured length capital L is the. So here it is given the above the mean line, 1 and 2 profiles, and below the mean line 1 and 2 irregularities are given. So option A 0, option B 1, option C 2, option D is the 4. So now we have to determine the RA value. So we know that when the RA equal to the H1 plus H2 plus H3 up to the Hn divided by small n. So here you have to consider the only absolute values. We should not to consider the any sign for the height. So here above the mean line, so there are the 2 irregularities are there. So height is the, that is the y1 and y3, height will become the 1 and 1. Similarly, below the mean line there are the 2 irregularities, that is the y2 and y4, height is the minus 1 and the minus 1, but we have to consider the absolute value. So y2 value is 1 and y4 value also 1. Then RA will become the summation of y1 plus y2 plus y3 plus y4 divided by the 4, and y1, y2, y3, y4 values are the 1. Then RA equal to the 4 by 4, which is equal to the 1 micron. So option B is the correct answer. Next we will discuss the one more problem. Assume that the surface roughness profile is triangular as shown in the schematically in the figure. If the peak to valley height is the 20 microns, then central line average surface roughness, that is RA value is in microns. Option A 5, option B 6.67, option C 10, and option D is the 20. So let's see the solution. So here given profile is the symmetrical triangular profile, and we know that one for a symmetrical triangular profile RA value is the h by 4, where the h is the peak to valley height. So in the data it is given the peak to valley height is the 20 microns. Then RA will become the 20 divided by 4, then which is equal to the 5 microns. So option A is the correct answer. And thank you.